Alright, let's finish up section 10.2 today. And yesterday I touched on briefly that this was a tough one because it wasn't in that nice graphing form, so we're going to have to do some rearranging. Notice that the x is the variable that's the squared, so we're going to keep those together and rearrange it. Leave a space here. Alright, because we left a space here, something should be ticking off in your head. Do you recognize that we're going to have to complete the square? Take half of the 6, 3. 3 squared is 9, so we'll add 9 here. This factors then into an x plus 3, quantity squared. 4y plus a 10. And then because the x is the term that's squared, we want to solve for the other variable there. So let's solve for y, which means we'll subtract that 10. And we'll have 4y is x plus 3 quantity squared minus a 10. Divide out the 4. Y is 1 over 4 times an x plus 3 squared minus 10 over 4. Putting in that nice graphing form where we can see what that p-value is, it's going to be 1 over 4 times a 1 times an x plus 3 squared minus a 5 over 2. And right here we see that p is 1. And because this is a y equals, we know that the graph will open up or down. P is positive, so we will open up. We'll need to find the vertex, the focus, the directrix, and the endpoints of the lattice rectum. Let's start graphing. We see the vertex is going to be at -3, -5 halves. There's the vertex. We know this parabola is opening upwards, so it has to do something like this. P is 1, so the focus is up 1 unit from the vertex. That focus will be then at -3, -1.5, or -3 halves. The directrix is down 1 unit from the vertex. So that directrix is going to be at y equals -3.5. Endpoints of the lattice rectum. We have to go 2p from the focus, parallel to the directrix. So 2p is going to put that right here at -1, -1.5. And then the other one's going to be at -5, -3 halves. And once you have that, then we can sketch in the parabola. Isn't that pretty? Alright, let's flip it around now. Instead of me giving you the equation and then you giving me the graph and the information, I am going to give you some information and you guys give me the equation. Generally when we do these, we want to make a quick sketch of what's going on. Perfect sketch? No. Reasonably close? Yeah. Okay, the vertex is at 3, 0. Directrix is at y equals 7. With that being the directrix, that tells us that this parabola is going down somehow. So then we know it's going to be a y equals equation. 1 over 4p, and we'll figure that out in a minute. Vertex is at 3, 0, so we can do x minus 3 quantity squared plus a 0. P is the distance between the vertex and the focus, or the vertex and the directrix. And this distance right in here is 7. And because the parabola is opening down, P is going to be a negative 7. Cleaning this up, y is negative 1 over 28 times an x minus 3 quantity squared. Alright, look at this next one. Again, quick sketch. Alright, focus is at 2, 4. Directrix is at x equals negative 4. Alright, that's enough to tell you your parabola is something over here. It's going to open sideways somewhere. Alright, so if it's opening sideways, that means this has to be an x equals 1 over 4p. Don't know that yet. We'll figure it out in a minute. Y minus the y coordinate of the vertex. We don't know that. Plus the x coordinate of the vertex. Alright, so P is the distance from the vertex to the focus and from the vertex to the directrix. Well, how far is it from the directrix to the focus? From a negative 4 to a 2, that distance is 6, which means that this vertex, I'm off a little bit here, we'll fix it in a moment, has to be right about there. It has to be halfway in between. So I'm going to fix my parabola here because it's bugging me. Something like that. That's a little cleaner. Alright, so that distance from the vertex to the focus has to be a 3 then. So that can be plugged in here. The parabola is opening to the right, so that will be a positive 3. We can read the coordinates now because that distance is 3, so that vertex has to be at negative 1, 4, which puts a y minus 4 here and a minus 1 out there. And clean that up a bit. 1/12 times a y minus 4 quantity squared minus 1. Alright, look at this next one. Vertex is at 0, 0. Ooh, right off the bat, that's nice. Vertex at 0, 0. Line of symmetry is the x-axis. 0, 0. Line of symmetry is the x-axis. So that tells us that this parabola is either opening to the right or to the left. But we know more. This parabola contains the point 2, 3, which means the parabola has to open to the right. Something like that. It's an x equals 1 over 4p. Vertex is 0, 0. We have this. Alright, do we know what P is? We do not. We only know where the vertex is. We don't know where the directrix is. We don't know where the focus is. So we're a bit stuck until we remember this point, 2, 3. So we can put those coordinates in. X is 2. Y is 3. I'm going to multiply by 4p to clear the fractions here. 8p is 9. P is 9/8. Awesome. Not done though, because we want to write the equation of that line, of that parabola. So plugging back in, x equals 1 over 4p, 4 times 9/8 times a y squared. Ooh, that's ugly. Let's clean this up. 4 times 9/8, cancel, that's 9/2. So we have x is 1 over 9/2 y squared. So x is 2/9 y squared. There we go. That was nice. All right. I wish I was there in person to explain this to you and help you see the information that's going on. I'm going to do my best here. We're going to talk about paraboloids of revolution. And a paraboloid of a revolution is a surface formed by rotating a parabola about its axis of symmetry. That axis of symmetry is kind of running right down the middle here. And here's this parabola. Can you imagine this parabola sitting out here like this? And then we're going to take that parabola and spin it about its axis of symmetry. There's some important pieces of information about this paraboloid of revolution, and one of those pieces says the following. If a light is placed at the focus, all of the rays of light will reflect off the surface in lines that are parallel to the axis of symmetry. Beautiful examples of this are a flashlight. Imagine a flashlight when you take it apart and you take that silver piece out, that silver curved piece that's in there. That's a paraboloid of revolution, and the bulb is at the focus. So the light coming out of that bulb hits the curved surface and it reflects out ahead of you. Headlights, spotlights, etc. All those are examples of paraboloids of revolution. It works the other way as well. So if rays of light emanate or come from a faraway source, like the sun, those light rays emanate from a faraway source. They are essentially parallel. And those rays strike the curved surface and are reflected back to a single point. Guess what that single point is called? Called a focus. Very good. Examples of this, a satellite dish, telescope, solar energy panels. All of those things take that light source or information from outer space, if you will, and bring it back and focus it so that we can look at it. All right, let's take a look at a couple of problems here. A cable receiving dish is in the shape of a paraboloid of revolution. Find the location of the receiver, which is placed at the focus. So there's the receiver right there at the focus. If the dish is 6 feet across at its opening, so right here, that's 6 feet, and it's 2 feet deep. A bit awkward to try and maneuver around and deal with this, so what we're going to do is to actually draw a cross section of that paraboloid of revolution. And you can put the vertex of that parabola anywhere you want. It's easiest to put it at 0, 0. And then I'm just going to kind of draw this satellite dish out here. And that satellite dish doesn't keep going, it stops. And it stops when that distance is 6 feet. This distance, its depth, is 2 feet. And we want to know where the receiver is, so we want to know where that focus is. Well, if we try to write the equation of this parabola, it's opening upwards, so we know that it is a y equals. And we put its vertex at 0, 0, so we'll have 1 over 4p times x squared. P is exactly what we're trying to find. Where is that focus? Okay, well, looking at this picture, can you tell me the coordinate of that point right there? Yeah, 3 this way, 2 up, so that point's 3, 2. Can we put that point in here? 2, 1 over 4p times a 3 squared. Gosh, these numbers look familiar. Didn't we just do this a couple minutes ago? We did. So p is 9/8. That's what we're looking for. But we still have to describe where is that receiver. Well, that receiver is 9/8 of a foot away from the base of this dish along the axis of symmetry. The receiver is 9/8 feet from the base of the dish along the axis of symmetry. If you've missed any of this along the way, feel free to ask the substitute or who's ever monitoring it to pause it, let you catch up, and then you can pick up later. You can always go search out my channel and find it as well. All right, so let's move on. Let's do this next one. A sealed beam headlight, so here's this headlight, is in the shape of a paraboloid of revolution. The bulb, which is placed at the focus, is 1 inch from the vertex. The depth of this light is to be 2 inches. What's the diameter of the headlight at its opening? All right, we have a kind of a nice view, but it's a little bit on an angle, so we kind of have to take that into account. But we can probably draw the coordinate axis and get everything we need right on top of this. It wasn't as kind of sideways, if you will, as the last one, as that satellite dish. So if we put this on here, and we see this parabola, that cross-section parabola coming out this way. See the light in here? There's your light, right there. That light is 1 inch from the vertex. And the depth of this light, so from the base all the way out to the edge of the glass, all the way out, I don't want that one, all the way out to the edge of the glass, I want that to be 2 inches. What is the diameter of the headlight at its opening? This is what I'm looking for. Diameter of the headlight. All right, let's write that equation. Our parabola is opening sideways, so that's an x equals 1 over 4p. Oh, and convenient, we put the vertex at 0, 0, y squared. Oh, now on this one, we know what p is. From the vertex to the focus, that's 1. That means our equation looks like this. 1 over 4 times y squared. All right, now, if we know this distance, we can double it to get this distance, to get that whole diameter. So that distance is what we're getting when we're plugging in x is 2. So put in x is 2, y squared is 8, y is plus or minus 2 square root 2. All right, what's that telling you? This distance right up here, or that point right there, is 2 comma 2 square root 2. This point right down here is 2 comma negative 2 square root 2. So that diameter is 4 square root 2. Inches. All right, so far? Whew, one more. I like this problem because it's kind of fun when you think about how big this is, and we'll talk about it in just a minute. A mirror is shaped like a paraboloid of revolution, and it will be used to concentrate the rays of sun at its focus, creating a heat source. If the mirror is 20 feet across at its opening and it is 6 feet deep, where will the heat source be concentrated? All right, I don't know if you can tell, but what's going on here on this big curved mirror, first off, it's 6 feet tall. 6 feet tall, 20 feet wide. 20 feet. Okay, this room is about 20 feet from, I think it's about 20 feet from front to back. So this curved mirror is big from the front to the back of this room, and it's as tall as, who's 6 feet tall in here? Okay, whoever that is, thank you. Stand up. Come on, stand up. 6 foot tall, as big as this room. Oh my God, that's a huge mirror. Can you imagine that? Look what they're cooking. It's a steak. Yeah, so they've got this heat source in here. We want to use the sun's rays to concentrate that and cook a steak that's in here. That's a piece of steak on a kind of a flat iron surface there. And it's just fun to think about, don't you think? All right, this one's actually pretty nice. We can almost see the parabola right on top of this. vertex centered at 0, 0, and opening upward. Okay, where's the heat source concentrated? We're looking for the focus. So y equals 1 over 4px squared, because opening upward, I don't know what p is, that's what I'm looking for. Where is this thing? All right, can you get me some coordinates to plug in? Got that right there. Yeah, 10, 6, plug that in. 6 is 1 over 4p, 10 to 10 squared. It's 24, p is 100. Divide this out. 25 over 6, which is 4 and 1/6 feet, right? 4 and 1/6 feet. So this heat source will be 4 and 1/6 feet from the base of the mirror along the axis of symmetry. Phew. Okay, thank you very much. That should finish up parabolas. Yep, it does. So we will hit ellipses tomorrow. Finish up section 10.2 homework, please. Be ready for a section quiz on 10.1 on Thursday. Have a good day.